Welcome to Refactor This, sponsored by vFunction. In each episode, we talk application modernization tools, concepts, and advice with industry experts.
Hi, welcome to another episode of Refactor This. My name is Amanda McGuckin-Hager. I'll be the host of this episode. Joining me today, I'm really excited to have Mark Richards with us. Mark is a hands-on software architect. He's been doing this for many years. He's also the author of 7 O'Reilly books, including the one that I'm holding in my hand right now, Software Architecture, The Hard Parts. This is modern trade-off analysis for distributed architectures. And we'll have this linked in the show notes. In addition to all these things, Mark has a website, Developer to Architect, where he has a bunch of different resources for those developers that are looking to move into architecture. I think there's some training courses there as well. So welcome, Mark. Is there anything else you'd like to share with us?
That kind of sums it up, Amanda, actually, although I'll just add a couple of things. As you'll tell from my color of my hair, I've actually been in the industry for 37 years, and it's a long time.
Good. That's great.
And 27 of those as a software architect. So I've had quite a bit of experience in a lot of different platforms and technologies and different types of architectures. But, you know, about, I guess it was close to about 6 or 7 years ago, I just suddenly realized that I had amassed all this knowledge, and I was basically doing some conferences and stuff, but it was about 90% consulting and 10% doing conferences and small little training things here or there. But it suddenly dawned on me that I'm really not serving the industry very well by being buried in a development team working. And so I started to make that transition shift, more of a 70% training, 30% hands-on architecture stuff. And anyways, that's been about 6 years I've been doing that, and I absolutely love it now. I still keep my hands dirty with consulting gigs, but mostly what I do now are conferences, workshops, and trainings, which I absolutely love. So that's where I'm at now.
That's awesome. It's such a good way to give back to the community and to share everything that you've learned along your journey and through all your experience and everything that you've seen. So I love to see that. I love it. So that brings me to my first question for you, which is, in this vast experience that you have, everything that you have seen, and in your consulting gigs and in your trainings, I'm sure you hear this come up, but you're familiar with the 7 R's, or sometimes it's the 5 R's or the 9 R's. And if you don't know that, I'll be sure to put it in the show notes for those of you to refresh, to get familiar with that. But it is a hot topic that I see a lot in the market. So, and one of those is refactor. So in your experience, what does it mean to refactor an architecture?
Oh, well, first of all, before I answer that question, thank you for actually having me on the podcast.
Oh, you're so welcome.
And
we're so glad you're here.
When you sent the invite, I kind of figured that the context of the podcast was about refactoring. So I love your question, because so many times we think about refactoring our source code. And there's so many great books out there about refactoring and different techniques and stuff. But when we start talking about software architecture, do you refactor an architecture? And of course, the answer is yes. But coming back to your question, what does it mean actually then to, quote, refactor an architecture? Because isn't an architecture just made up of source code? Well, in my mind, what it really means is kind of changing the structure of the system, as opposed to maybe satisfying some technical debt, which, by the way, I'd love to get to in a little bit. But it really means changing the structure of the system as opposed to the source code. And now I'm sure the follow-on question is, okay, but like, what does that even mean? Like, what do you mean change the structure? Because it's all just zeros and ones at the end of the day.
Right.
Well, think about it like this. Okay, let's say that you've got your house. Now, your house or the home that you live in has a particular structure to it. And let's say that you want to add an addition to it. That's changing the structure. If I replace the carpeting in my
Mhm.
living room, that's a refactoring that I'm doing to my home. But it's not really changing the structure. It's just changing the color of something.
Mhm. It's not the
Maybe
architecture, is it?
right. But once I start moving a wall,
Mhm.
adding an addition, putting on a deck. Um, ooh, how about this one? I want to change my one-story house to a two-story house. Now that's a major refactoring. But these are the kind of things that I'm talking about when I refer to refactoring in architecture. So if we take that kind of analogy of kind of a house or a building and think about that structure, that's really what we're changing or refactoring to, well, improve it or make it better. Some good examples are adding or removing services within a microservice or any kind of distributed architecture for that matter. Anytime we deploy a new service or remove a service, that's changing the structure of that system, just like a
Mhm.
room in a house or an addition. Um, let's see, communication protocols, changing some of those, moving from maybe a RESTful call to maybe messaging or streaming or something like this, is changing the structure of it. Even migrating to a different database is another good example of a structure. That database is something we're communicating with. One other good example, so that we get an idea of the architecture, is even if I have to now communicate with a service
Mhm.
that I never had to communicate with before. I'm coupling services together. I'm drawing a line between two deployment units. That line is part of the structure of that system. These are examples of what it means to kind of refactor an architecture.
Those were great examples. Thank you for the analogy. I am not a software architect, and I appreciate the explanation, being able to follow along. So, but that does lend itself to my next question, which is, what is exactly the difference between code refactoring and architectural refactoring?
Well, it's interesting. It sort of lends itself or leads off of that prior question. But a good difference between code refactoring. If I think about code refactoring, for example, I might think about changing an algorithm,
Mhm.
improving a search query,
Mhm.
tuning. Oh, here's another good one. Tuning a SQL statement, SQL statement for a
Mhm.
relational database. Maybe applying or paying down some technical debt by actually cleaning up my code and making it more maintainable because I had to rush through it.
Mhm.
Maybe breaking apart a method, or I'm sorry, breaking apart a class, or even a method. Code refactorings that we do a lot. And there's a lot of refactoring patterns that have to do with the structure of our code.
Mm.
But the difference between code and architecture refactoring has to do with that structure piece. Service granularity is a really good first example between a code refactor and architecture. Now, if we talk about maybe breaking apart a service or putting a service back together,
Mhm.
certainly it does involve source code. I mean, we're breaking apart our classes into two separate deployment units, maybe even two separate repos, depending on how it's structured. Um, but again, we're changing the structure. So that would be a good difference between an architectural refactoring and a code refactoring. Again,
Mm.
we're changing the structure. We're varying the granularity of a service. A service may be doing too much or not enough, or because it's talking to the same database tables, maybe we combine it. Um,
Mhm.
Another good example of a difference between code refactoring and architectural would be changing a communication protocol. Uh, Maybe going from a RESTful call to maybe Google's remote procedure call, gRPC. is, again, involves code,
Mhm.
but notice we're changing the structure of that system again. Modifying a contract would be another really good example. Now you might think, wait, Mark, contracts is code, and it's true, but a contract is a dependency between parts of our system, especially in
Mhm.
distributed architectures like microservices. And at least it's my view that when we modify a contract or change a contract, add something to it or modify it in some way, I see that as an architectural refactoring because it is influencing and impacting other parts and structures of that system, other services. Um, Breaking apart a database involves a lot of code,
Yeah.
but it's also structure. So the real difference, again, between a code refactoring and architecture, and it does become confusing, doesn't it? Because, well, but Mark, I've got to write some code, but I'm not changing the structure of that code, changing
Yeah.
the structure of my system. So that's really where those differences kind of part ways. Yeah.
Yeah. So going back to the home analogy, replacing carpet, new paint, maybe even changing a bedroom to an office. Those are changes,
Great example.
but not architectural changes, right? But adding another bathroom or, converting the garage, or those are more structural changes, especially if you're replacing the garage door with a real wall, right?
Yeah,
Those types
exactly.
of things.
Yeah. Michael Nygaard, a friend of mine, a great architect, when he kind of coined, or not coined, but evangelized architecture decision records, he said the things that we should make decisions on are architecturally significant things, kind of coming back to our question about, well, if I refactor, how do I know it's architectural? And he had
Yeah.
a great definition of these. Um, um, Services, the corresponding interfaces, the dependencies between these services or components. It doesn't have to all be distributed. These all could be
Mhm.
components within a monolithic architecture, like a modular
Mhm.
monolith or layered. But those are the kind of things he identified, things that impact the architectural characteristics, those ilities like scalability or
Mhm.
availability, performance, these sort of things. And it was a great example. If I'm touching those kind of things,
Yeah.
then it's architectural.
Yeah.
Um, and then it's still refactoring, but it becomes more architectural as opposed to coding or design. You know?
So let me jump into well, let me ask you this question. How do you manage and control architectural refactoring? We just discussed a lot of the definition of architectural refactoring versus code refactoring, but how do you manage and control, especially if you're looking at monoliths, right?
Oh boy. Well, yeah. And as a matter of fact, I'm so glad you asked that question, Amanda, because now I can launch into one of my soapboxes. I've got so many soapboxes, but this is one I really love, that um, architecture refactoring, problems that we have in architecture, is not the same thing as technical debt. So often, and I don't know why this is the case, it just is, that we associate refactorings with a way to pay down technical debt. And
Hmm.
I don't necessarily agree with that, although it seems like that's most of where refactorings come from.
Hmm.
But I
Tell me
just,
more about that. I'm really interested.
yeah, so and I will get to your question. You may have to repeat it, but I will get to it. But the point is, it's when we talk about managing technical debt and the refactorings that occur to pay down
Hmm.
that technical debt, which is, again, pretty typical. It's not
Hmm.
always the reason we refactor, but it's a common reason. Um, oh boy, where do I start with this tangent? Okay, here's where I'll start. um, uh, if we have to change something in the architecture,
Hmm.
that's the structure, break apart a service, combine services together, change a protocol, maybe apply the backend for front end pattern, break apart a gateway,
Change
an
of
API gateway.
dependency.
Yeah, these are all things that we're doing. And are you ready?
Hmm.
Because they are impacting an architectural characteristic, something like scalability, elasticity, maybe it's data integrity or availability, reliability. And those, Amanda, directly translate to business concerns. That's where they
Business
come
value.
from.
Mm-hmm.
So technical debt, I view as bugs in the system. Some of those are major, some are minor.
Mm-hmm.
Some are just things that I don't like the way I coded that, but I don't want to spend my weekend doing it, so I'm going to mark it as technical debt. but it's not. It's different. So I want to start with that. As I remember your question correctly, it was how to manage and control architecture refactorings.
Mm-hmm.
So I wanted to kind of do that tangent because we talk about managing technical debt. Well, it's really not.
Mm-hmm.
One of the ways that I do manage architectural refactorings is if I see, and I'm going to use breaking apart a service because that's such a common and great example.
Mm-hmm.
That's a refactoring to source code, but more to the point, it's a refactoring of our architecture.
Mm-hmm.
But what kind of story is that then? And what I like to create to manage my architectural refactorings are what I call and use architecture stories. It's not
Ah,
technical debt story. It's not a user story.
right.
It's not a technical story. It's an architecture story. And the reason I like managing architectural refactorings through these stories is because now I can provide an estimation for them, first of all, but
Mm-hmm.
also, and this is probably most important, it gives me a vehicle for negotiation. Because you see, any developer gets frustrated because we want to do some code refactorings. There are really these great patterns that would really improve the quality of the code. But nope, we can't fit it in on this iteration because we have too many story points for user stories, or we have to get these features out. An architecture story allows me to negotiate with a product owner to say, okay, this is a 3-point architecture refactoring. But here's the reasons why we need to do it. And it does translate to business concerns. We won't be able to scale in
Yeah.
3 weeks for that new acquisition. And that becomes a business concern. And this allows a vehicle for negotiation, but also a separate tracking
Mm-hmm.
for that kind of story. You know, a lot of times when we have all these things where we're changing some aspect of the structure, we struggle to how to record that, because
Yeah.
it's not a user story.
Yeah. No, but I love this concept because it is a tangible documentation that, as you say, can be shared around. It does build in the business value, which almost every decision gets made on what is the impact to the business? What is the expected impact to the business? And allows the architect and the team to get back to those illities, right? Which of the illities
Precisely.
will be benefited or will come as a benefit of this decision?
You hit the nail on the head, Amanda. That's exactly right, because I have no business changing the structure of my system if I can't justify it based on a particular architecture characteristic that translates to a business concern. Then I shouldn't be actually doing that architecture refactoring. And it really serves that purpose as well, to say, maybe I should hold off on this. But it's funny, I really don't care for the, as a user, I want to do this. But it's funny because in some consulting engagements I'm on, it still is required. So here's a good example of one of those. As a system, I need to be able to scale to meet the new demands of 100 concurrent consumers or customers that we now currently are measuring. I mean, there's a good example. And then it describes what I need to do in order to achieve that scalability.
And I'm sure it includes the consequences of not doing it, right? The customer experience or the degrading customer experience of 100 concurrent users if it's not done.
Right, exactly. Yeah. So it's a great vehicle, but that's primarily how I manage those. And it also requires, Amanda, some of that soft skill stuff of an architect, that negotiation skill, to know how to approach a team or a product, usually it's a product owner or a scrum master, to say, I really need to get this 4-point story in. Can we slip it in? No, we have no time. Then we're starting to talk about the impacts of it.
Mhm.
Now, maybe the impact can be delayed because of functionality that's needed in this particular iteration. But that's the way I typically manage architectural refactorings. And then they get assigned just as any user story would.
Yeah, it makes a lot of sense.
Yeah.
So you've been at this a long time. You've obviously learned some great things and developed some great approaches and tactics. What about some real world examples? Sometimes I love the theory, but I also love the practical application. And I know you've seen a lot of those. So
Oh, yeah.
what
Boy,
are some real world stories?
yeah. So some really good examples of real world architecture stories that I have written. Here's one that ends up for some reason being fairly common for some reason. As a matter of fact,
Yeah.
I've got several common examples. Most e-commerce or a lot of sites have payment services. I mean, we have to
Hmm.
pay for a service, we have to pay for an
Hmm.
item, we have a subscription payment that we need to do, maybe for a particular service vendor or something. Um, so we have a payment service, and we can take payments in a lot of different formats. Credit card, maybe if it's e-commerce, we have gift cards. Maybe I can have store credits. I can use PayPal, WorldPay, all of these kind of things.
Hmm.
A good example of an architectural refactoring is the hypothesis to say, I think we should break up that single payment service into 5 different payment types, 5 different services, one for each payment type. This is a real world example of an architectural refactoring. We're taking one single consolidated service with one single database that it owns, and let's assume we're in a microservices world where we do have a bounded context. So I've got a payment service, its corresponding data. I've got an API call that goes straight to that payment service.
Hmm.
Well, this architectural refactoring is a lot more than just breaking apart the service. And I love this real world example. Okay, yes, let's break it apart. And our reasons are because we do a lot of changes to, let's say, maybe credit card. And because it's a single consolidated service,
Hmm.
our testing scope is greater. I might miss something, I might break something else. My deployment risk when I deploy that service is a lot greater. And
Hmm.
so by breaking it apart, I can isolate that particular payment type to only that deployment unit, that particular microservice. This happens a lot. 2 of the most common architecture refactoring patterns that any of you listening will encounter are service split and
Uh-huh.
service consolidation. What I'm referring to is the service split refactoring pattern. Well, think about what I'm going to do. I'm going to take the code, and it's basically kind of moving it around into different directories, probably within my Git repo, to deploy as a separate unit of software, a separate microservice. But now I've got to break apart the data as well
Hmm.
to keep those bounded contexts, or I'm not really gaining anything.
Hmm.
So now I've got tables I need to start splitting up and moving around. Choices about what database works best for these to record all of this information. Then, are you ready for this? You've got another refactoring on there architecturally, because I've got a single API call going to that
Wow.
single payment service. But now I've got a choice to make. Do I split that up into different API calls fronting each of those 5 different payment services? Or do I keep the API the same, but maybe create an orchestration service that then
Mm.
manages, because I can pay for things with multiple payment types? Suddenly, guess what? I've changed the structure of my system, because
Yeah.
now I'm introducing orchestration that used to, by the way, Amanda, be at the code level, because it was just probably a method, a driver method, that now I have to create a structure for. I have to create a new service that has new communication points, and I have to reroute my API calls to that new orchestrator.
Orchestration.
So look at all that stuff I just described by simply just breaking apart a service.
One service. So let me ask you, it's fascinating for me to think about. Let me ask you, I know there are pros and cons to each solution that you presented, right? 5 API calls to 5 different services,
Right.
or 1 API call to the orchestration, orchestrating 5 different services.
Mhm.
How do architects make those decisions?
Trade-off analysis.
Okay. And
Any
that brings us
decision.
back to your book, actually. This
Right.
was
Yes.
this was impromptu, by the way. This was not planned.
Yeah, but really, the orchestration does have to happen, and now we have the decisions. Does that happen at the user interface level, or do we not want to address any changes in the user interface, but have the API be the same, that just forward it to a different kind of service? And there's trade-offs on each of those types. And
Mhm.
that's how we actually make a decision. And of course, you know as well as anybody listening, the real answer to your question was, well, it depends.
Yeah.
And that's the problem. It depends based
It
on
depends.
those pros and cons of where
Yeah.
should that orchestration happen. Yeah.
Yeah.
Um, so, creating 5 API endpoints and orchestrating that through a user interface might be a lot more complex than keeping the API gateway untouched and just re-forwarding it or redirecting it to a different service that then manages that. Because think about it, Amanda. What's involved with orchestration? This is another real world example, by the way, orchestration.
Great.
Because, well, can I call let's say I pay for something with a credit card and a gift card.
Okay.
Can I do both of those service calls at the same time, or do I have to do one before the other? What happens if I apply a credit card and the gift card service is down? I don't have a transactional unit of work, so error handling becomes very, very complex. Uh, who owns the contract for that consolidated order payment? These are all the kind of issues that come up with orchestration, which is another kind of architectural refactoring. Where should that be in the structure of my system?
Yeah.
Yeah.
Yeah. Well, it doesn't sound like easy solutions by any means.
No, it doesn't. Another real world example of an architecture refactoring is something that is also very common. Whether you have an API gateway, an integration hub, a message broker, a streaming broker, a lot of times these start to become bottlenecks in our system.
Mhm.
They start to become single points of failure. And we know that we can address single points of failure through usually clustering and stuff like this. However, even within the cluster, all of a sudden there's so many requests coming to any of those artifacts I just mentioned that we start to have performance, throughput, memory problems. Those are the most common, by the way, that I've experienced in any sort of gateway or hub, is memory. And so another real world example of an architecture refactoring is what's called federating or breaking up an integration hub, an API gateway. And this is so common. It's such a common architecture refactoring that of late, I usually make the assertion, why don't we have a separate API gateway or hub per domain, even especially in microservices? So we've got a customer API gateway, maybe an issuer API gateway, a policy API gateway, these sort of things, so that those endpoints are all managed within a particular context. By federating or breaking that apart, that is changing the structure of our system. Another real common architecture refactoring. And again, we're talking about availability, throughput, performance, responsiveness.
Yeah, absolutely. Well, do you have a success story to share where someone has gone through all these decisions, has looked at this vast, got sort of parsed through all these decisions, the architecture, made some trade-offs, and has seen any of those illities improve?
Oh boy, I've
Not to put you on the spot. We can cut this
no, it's
out.
not putting him on the spot. Oh, what came into my mind were all of the things that didn't work. No, there have been actually quite a few success stories in the nature or the context of architectural refactorings. And most of those, I will tell you, come from, all of those successes have actually come from knowing and qualifying and being able to get buy-in and justify the characteristics that are needed for that particular system. Those ilities we keep talking about.
Mhm.
All, and I will say all of my successes have come from knowing those first. Teams that I walk into a consulting engagement, it's usually my first question. Okay, do you
Mhm.
have a list of what, I have to use all the names, non-functional requirements. I call them architecture characteristics, ilities, system quality attributes. Do you have a list of those for this system or the different architectural quanta within that system? And it's surprising. A lot of teams say, yep, here they are. Some kind of turn their head and look at me and go, what do you mean?
What do you
Or
mean by that?
no. And so that's the starting point, because I will maintain this always. I cannot undergo any architectural refactoring until I know what those characteristics are. Because if we're changing the structure of the system, there's probably a reason why.
Mhm.
And we want to make sure that that reason is well justified and benefits the business, that it has business value, not just cleaning up the system.
Yeah.
Because architecture refactorings, I want to come back to the managing question really quick. And then, so we'll
Okay.
table this one,
Okay.
because the other management piece I forgot to mention, especially in architecture, are small, incremental, controlled changes.
Mhm.
Changing architecture
Iterative.
is not as easy as changing code.
Mhm.
And we can break a lot of things. So I tend to keep those fairly small scoped, if possible.
Mhm.
Anyways, I just had to regress from that.
No, it's a really good point. It is a very good point. I'm
Um,
glad you brought it up.
yeah, but no, those successes have been in the realm. I'm just thinking of another one that was fairly recent, of migrating all of the RESTful calls to specific services behind the scenes
Mhm.
over to gRPC, Google's Remote Procedure Call, using HTTP2 with protocol buffers. And that ended up being a great success. We had a driver for that. We needed the sheer raw performance that socket level connection, that RPC connection made. Knowing cost would be high because we needed a
Mhm.
load balancer for the gRPC,
Mhm.
specifically gRPC LB, but now we're getting into the geeky stuff. But also, that was a success because it wasn't a slam dunk decision. Because what we did as a team was analyzed the trade-offs,
Mhm.
because we tightly coupled all of those services together because it's an RPC call. So these services had a high dependency now because it's still a skeleton. I've got a piece of your code. It's like a method call. So the point is, we balanced the choice between how much additional performance did we require? Was it worth the trade-off of
Mhm.
coupling those services? And we deemed as a team that it was.
Yeah.
But the reason for that success is that we paid attention to and tried to mitigate that coupling between those services. So and that it just worked out. So it's how, I don't know, I think about that particular project, Amanda, because it was how things are supposed to work.
Well, and
The
I'm
team
sure it's something that keeps you going, right? When you see the
yeah.
success of your clients and your customers and your friends, it's a lot. It's
Yeah.
very rewarding.
Yeah.
Well, Mark, this has been a fascinating conversation. I know that I'm going to drop a number of things in the show notes, including your book, the link to your website. If you have an example of a architectural story, we could point that
Yes.
out in our show
Oh,
notes.
Yes, indeed, indeed. Yes. As a matter of fact, in my lessons, two things. Lesson 112 is a worksheet that I've created for architectural characteristics. I mean, we talked
Great.
about a lot about refactoring, Amanda, in this, but we
Yes.
also talked a lot about why to do refactoring. And that lesson kind of gives resources to that architecture worksheet, the characteristics worksheet I use. Absolutely. But also, let me just do a really quick search here. Wait, stories. Yes, I do. Lesson 106 in
Okay.
my Software Architecture Monday is on architecture stories. It goes a little deeper into how I described them and actually shows them in action, shows an example of one. So those are
Awesome.
two really good sources for those refactorings.
Awesome. I'll definitely drop those in the show links
Yeah.
for everyone listening.
And there's so many more. I just don't want to search for them, but I do have a lot more on how to refactor microservices, for example. But if you peruse the catalog in the lessons tab or lessons link in the menu, you'll see, well, I've got 154 of them out there now, but
Good
you
for
can do quick
you.
searches to see, refactoring microservices, et cetera.
Good for you. And as a reminder to everyone, these are on Mark's website, developer2architect.com. I'll have that link in the show notes as well. Mark,
Awesome.
thank you so much. It has been
All
so
right.
much fun. I really appreciate the time and sharing your experience and expertise. And thanks again. This
Okay,
concludes
well,
our,
thank you again for having me on the podcast.
thank you for being here.